Welcome. Okay, sorry for the delay. Sorry, Steve, to making you wait. For making you wait. So, a little bit of technical issues. YouTube changed something with the chat, so you see like there's this like weird disclaimer now in a chat window. I managed to remove the sign in button, so some stuff is fixed. Super annoying. I just realized that like 10 minutes before the stream and I have no time to fix it, and for some reason like the CSS overrides I put on the chat window in OBS, they don't work. But yeah, let's go to the fun stuff. We left off last time. I still need to like get something taller here. We left off last time with the bottom being installed, I think. Yes, but I had the rods cut to the wrong length. So I basically fixed this like quite quickly after stream. I just cut the rods to length, added them, and the rest kind of like stayed as is. I noticed we made a mistake. This part here is flipped. Like this should be here and this should be there, and like this golden insert here should be on the bottom. Hi there, Jim. So yeah, that's at some point we need to flip those around, but it's not a big deal. Then besides that, I of course worked on the bed mount. So I basically designed that. These are the prototype parts. We will like remove them in a second. You see like it doesn't quite line here with the belt. Like it's not quite there yet. So I made some tweaks. Yeah, but this is basically what we have so far. So you can move it up and down already, which, hey, it does something. So we'll remove this, and then I have lots of parts. So basically these are all the parts we need to make it move. So these are the final versions of the bed mount. Some parts are not here yet, like these clamps. I designed like very simple twisty thingy. Like it's not quite like a wheel, but like to adjust the bed. So that's all here. The eagle-eyed amongst you spots some parts for a mini stealth burner. And that's also what we have here now. So one thing I printed, and I couldn't help myself but put it on the printer. So we have like a mini stealth burner here. Which will be what we'll use as a tool head. I should have removed the Voron logo maybe. It's not a Voron, but hey. So that will be the tool head, and this one is a bit of a special version because it has two holes for magnets here, and this is actually for a clicky probe. So we will have a clicky probe here. I'm not quite sure yet how to mount the dock for the clicky. I'm kind of thinking of having something here in the front where basically the mount is here. And there's like a project for the V0 which is called slide swipe, which basically twists the dock out, and then you have like the dock here and the toolhead can collect the probe. Maybe I can quickly show that. So that's kind of what I'm planning on going for. Light swipe, exactly this one here, and they have a no, that's very generic name seemingly. This one here, slide swipe. Give it a second. Yeah, so basically this is how it works on the V0, but we have the same tool head, and this is basically what I need to mount. So it's a servo that basically like brings out the stock, and then the tool head can collect it and put it back. Hi there, Big City Tours. Hi there, Rivonic. Lots of people already here. Yeah, so that's basically what I want to do for the probe. Challenge is we have to mount it somewhere. And the normal mount, of course, is made for the 1550 extrusions, which we don't have. So we need to be a little bit creative, but we'll find a spot. Then one issue I noticed while playing around. So we put the idler here in front, and what I didn't consider is basically that the tool head now collides with this idler. So basically this idler needs to be like ever so slightly lower. I think like 5 millimeters or something. And then that's okay. So we kind of need to redesign this like part in here, this like inner part. And a bit of resistance when I push. I need to check that. So this basically just needs to go down a bit. So we need to redesign this part. Not a big deal. We have a bit of like wiggle room here. So we can bring it down almost like 10 millimeters until like this has contact here. So that's quite okay. You said you started at 1930. Sorry, Paul. I tried to be a bit earlier today because I'm very eager to like get this to move. Speaking of get this to move, I actually have no clue where I put the mainboard. What's the travel on X and Y and bed size? The bed size is 180 by 180. So we use a Prusa mini bed, which is here. So this is basically this way up. So this is the bed. What I already noticed is I think in X and Y we basically get a full 180, but barely. But for X we get full 180, but for Y I think we are missing like a couple millimeters on front or end. So yeah, minimally. I think this part, like the XY joint here, is like a tiny bit too long. But this is actually something we could optimize, because if we move the tool head forward, like we have at least like 2 millimeters here where we can bring it more forward. And I'm pretty sure we can also shave off like a couple of millimeters on the back. Then we just like make this tiny bit like more narrow, and then we should get back the range of motion that we're lacking. But yeah, I'm also not super concerned about that. For now, let's get to print. Cool. But yeah, that's kind of like the introductory things. And on here properly. Then I guess let's start unbuilding first and get this out of the way. And then start doing stuff. Hi there, Martin. Because you might have enough space for a probe on the edge of travel. No, it's definitely like the edge of travel is like really edge of travel. Like, I mean, we can lose print volume, of course. But yeah, like my plan is really like to have it like in line, like just like below this rod here, because there's space. Nothing really collides there. It's just like the question is like how do we mount it? But I think like if we like redesign this part here, you see like basically we can make this like a bit longer. Oh, we cannot. Whoop, because this would collide them with the XY joint. Okay, challenge for another day. We'll manage something. Potentially we also have like lots of space here, so we can maybe mount it from the back. Also possible. Yeah. For now, basically, what I did is these parts of the bed, they have like a mounting point for the for end stop switches, basically. So we just have like 2 end stop switches left and right to home both motors, and then no probe for the beginning. So basically, I just wanted to get print first, and then we can do like probe and all the other fun stuff. Yeah, but let's just take this apart first. And then I think we, the YouTube chat distracted me so much. Like, I mean, by now it's almost gone. You need to chat a little bit more that the learn more button is gone. But yeah, they changed something in the chat, and like my styling didn't apply anymore. But yeah, I was so distracted that I didn't put out the soldering iron. So we need to grab that in a second. Or like, by we, I mean I. Well, let's first take this apart. Let's grab my screws. Let me just sort these back for now. And let me also like put these parts away that we don't mix them up. So let's see if I can kind of give you like a nicer angle on that. So we have like quite a tensioning mechanism here. So it has quite a lot of like range of motion of tensioning, so we can tension this like really nicely. I'm a bit concerned if we get the belts in night, because like all 4 belts need to end up on the same height, right? That's a bit of a concern of mine. Let's see if that concern is warranted or if that's not a problem at all. I'll see if I missed your comment. Why when your bed's going to be mounted away from the belt and idler? Not quite sure if I get that. The bed will be mounted a bit away, I guess. Okay. We also don't need these belts. We will use the proper gate belt. Oh. Potentially you can use them as a template to cut the belts. Okay, let me quickly grab my soldering iron, because otherwise we will be not getting very far with assembling the things without heated inserts. I'll be back in 20 seconds. Okay, 1 soldering iron. And then I guess maybe it's smart to first do like all the heated inserts of all the parts. Just get it out of the way. And then we can put everything together. Let's not make this mistake again with like 400 degrees and ABS. Always a bit smelly. Cool. Okay, let me quickly get the parts we need. So I actually have to like clean those up quickly. So these are the outside ones. Then we have a couple inside ones. Let's do these first. That's basically all the parts. Oh, also these. All the parts we need to basically get the gantry going. And the other parts, what we see here, are the ones we then... Oh, you don't see them like on the side there. These are the ones then for the bed mount itself. So let's start with these. Just quickly, I used some mouse ears because like this did not stick really well. And luckily they're really easy to remove. Yeah, oh, that's still warped quite a bit. Didn't see that, otherwise I've reprinted that. But yeah, all prototype parts. So my expectations for visual quality is really low. It works, it works. These mouse ears are pretty cool actually. Like Orca says I can do them by itself for now. Not always like super happy with the placement, but it's generally works quite well. And it's much easier to remove than like a full brim. Okay, I think these parts actually don't have any heatsed inserts. We can put them to the side right away. These have. these have. And these have for sure. And there's actually like, I added some inbuilt support, which worked reasonably well. Not perfect, but good enough. Actually breaks off quite nicely. Steve, I also added your suggestion. Maybe let me show it here, it's easier. So there's like a little lock now for the zip tie. So the belt basically goes in here. Like this. So the belt's now locked, but then basically you had the concern that this slips out on the side. So now there is this zip tie. So there's a little hole, and then hopefully, I didn't test it actually. Oh, comes out the wrong side. Okay, maybe we need to like improve that a bit. Yeah, now it works. So it comes out here, and now this is... It's a bit tight, but works. Here we go. Now this is completely locked in. Like this doesn't get out anymore. And also like this, like it's quite, you really have to pull to get this out actually. Okay, let's do some inserts. Martin, I'm not sure if I ignored your hi, but hi, in case I didn't do it before. Oh. Part 1 done. 50 more to go. It's actually quite funny, like, these parts were way too close to the bed. I always struggle on the V0 with the Z offset being different, but I think I finally figured out what the issue is. Like, so on the black parts, I have it quite well dialed in. Like, these are really good. But the turquoise parts, they're always too close to the bed. Now finally figured out, and it's quite obvious if you think about it. The bed temperature for black is 100 degrees, and this is 110 degrees. And seemingly this 10 degrees difference caused the bed to just be like expanding a bit more, and then being closer to the nozzle. Louis said hi earlier. Well, better twice than once. Or twice than none. The soldering iron has more tech built in than my phone. I think it's quite a simple. It's not an expensive one. It just has a display. That's the only thing it has going. I think I paid like 30 euros. Okay. One color done. Actually, only a couple more parts. Let's also do these for the end stops. I actually don't have enough end stops, so we have to cannibalize the X and Y end stops for now. I think X and Y we can home sensorless anyways, now that we have like a board that can do that. Initially when I started this build I wanted to use like the old Ender 3 board, but yeah, we don't do that, so we can just use sensorless homing on X and Y. But then for that, later I think we can just use the probe to home, like when we have a probe. And there's actually something, I forgot the name for it, but what Clipper can do seemingly is probe in multiple points, and then even with 2 motors can like tram the bed for you. There was a bit, one of my concerns having like two Z motors, that you kind of have to like tram the bed, because like technically motors can be out of sync. Like not technically, they will be out of sync if you power off the printer. These small parts are holding the other end of the belt. So that's what we are tensioning. Did you ever thought about a device for soldering iron to press in all inserts? Yes, I actually printed all the parts for one, like in the... So when I... before I started building like Voron printers, I used like bad inserts, I can say. Actually still have quite a lot. Like these type of inserts. That's what I started with. And that's actually quite bad. Like they're really hard to press in straight. And I tried to do it with a normal soldering tip. And like I blew so many parts. Horrible. But... Yeah, now it doesn't fit anymore. Where did I take this out? Too full. Okay, whatever. Works. So for those, I definitely considered having like a press. But then basically like these are going in so easy that like I don't feel like I need it. Like it's just an extra thing I have to have on the table and like store somewhere. So yeah, I'll just do it by hand. That works quite well for me. Your new ones are from CNC Kitchen. No, they're just like the generic pizza insert. Like I know CNC Kitchen has similar ones. They're like a little bit different. But if you you get them on AliExpress, or like let's just heat set insert, and that's I always get 3, 4, 5, I think. Oops. Yeah, here. No. So I wanted. Yeah, these are the ones from CNC Kitchen. Oh. I think they're pretty much the same. They're just a bit different, I guess. Yeah, but I usually buy them on AliExpress, and I buy like packs of like 200. So I have quite a lot. Because yeah, I use quite a lot of those. Okay. Then we have all the parts. Let's see. So what would be the plan? I think we can assemble the parts first. Yeah, I think it's smart if we have the belt at least in. Because basically how these work. These are the back ones. We start with the front. So these are front, and then this is back, and this is back. Okay, so these are the front parts. So how they work is, let's do it with this one. The bearing comes in here. So that basically locks in place here. convince the camera to focus here. So the bearing goes here. Can you please focus? Oh, be very... Oh wait, I'm in the wrong focus mode. Give me a second. That explains a lot. Okay, so now we have focus. Amazing, right? So these go in here, and then there is the outer part, which basically, is this the right one? I think they're kind of like identical, to be honest. Which comes over it. Yeah, that's the right one. So that basically goes in here. Then we have the belt being clamped here in this little slot from the top. And then the other belt, there's a little hole in the back. The belt goes in, and then we clamp it in this black part. And the black part basically is in here and can be tensioned upward. This is the wrong one, but yeah. So this can be tensioned upward. There's a screw basically going from top to bottom. Just basically going all the way. And then we can like tighten the screw, and the screw will pull this little like slat up basically and tension the belt. So that's basically how these work. The back parts are identical from concept. So basically they just don't have the this one. They just don't have the bearing. So we only have 2 bearings because it's enough to like secure the bed in X and Y, right? Like the bearings only need to prevent the bed from moving left, right, forward, backward. The belts are what hold the bed up basically. So we don't need extra bearings on the back. If you would have 4 bearings, it would get more difficult to align everything, right? So basically now you have to have 2 rods that need to be perfectly parallel. If you have 4 bearings, you need to have 4 rods that need to be perfectly parallel, otherwise you have binding. So yeah, just easier to just have 2. So these are exactly the same. Yeah, so these parts go in here, just tighten the rods here. And then we have the same slat, or like almost the same, that goes in here. Maybe we need to like stand there a little bit. But then basically tension upward, and the other belt is on the back here in the slit. So it's really straightforward actually. And then we just have this 4 times on each corner. Okay. Belts. Let's get all the cheap belts out of the way. I kind of like the idea of using this belt as a template. So this is the cheap belt I used in the beginning now for prototyping because I didn't want to cut the gates belts. But now it is time to cut some belts. So I just put it like teeth and teeth, and then you can just pull it down. And as long as you don't let go of the center part here, you can just step by step pull them along. Always have a backup, I guess. I hope I have enough belt, to be honest. Okay, this is one. Worst case, we have to use the cheap belts on one side for now. But it really, like, they're really not good. Like, they're cheap for a reason, I guess. I mean, these are the two long ones. These are the front ones. Okay, so these are the two. And then we have two short ones. Woo! Might just be enough. I thought I ordered like plenty of belts. Let me quickly do it again. I don't trust it. Okay. Let's say somebody wants to build your printer. Will you publish it? Yes, definitely. It's just like at the moment, it's not ready. So I definitely publish it. And I know I also said it about the PC case. PC case, we still need to finish. But yeah, I definitely want to publish it. If it's a good idea to build this, I don't know. Let's see when it's done, right? Like this could be like horrible. Like at this point, I'm not even sure if it will work. I think it's quite a cool machine. It's definitely unique. So it's different than the other printers because it doesn't use extrusions. But yeah, like definitely I will publish. Whatever I have at the end, I will publish, and then everyone can decide if that's like something they want to spend their time on, or money as well. Like my plan at the moment is like to finish this like as it is now. We want to add the probe. There's like still some electronics compartment missing, right? I need to figure out how to do the back panel. But then I will publish it, I guess. My goal personally is to improve this a bit further and loose screw. And I want to add panel like enclosure panels basically. I'm not quite sure yet if this is possible or like what it would take to do that. Like it will definitely like require some redesign. We also have to work still like quite a bit on like the parts up here, so it's definitely not final. And I want to have it in a state where I can use it in printing reasonably well before I publish. But yeah, yes. Long story short, yes, I will publish. Cool. Then let's start with pulling in the belt. So this is a short one. This is a short one. Let's take the short ones to the side and start with the front ones, the long ones. So we put this in. Let's just make sure that it's somewhat the same. Then we can like use the belt length as a measure. Oh, maybe not the same belt. There you go. And just compare that, like, yeah, it's like one full T. Yeah, that looks good. That's the same. So this is now like clipped in here, and like you can really pull on it. Like this doesn't. It's just a bit of plastic, but like it doesn't come out. I actually like tweaked those. I think I printed like 4 or 5 versions of this part. Because so basically I first had the top part where the teeth are like quite thin, like only 2 millimeters. Now what happened when you pulled this bandit out basically. So it just like it took me a second to like figure out how much plastic I need top and bottom. And then basically there's just like little like dovetail joint basically, and there's like a little hook, and that just holds it in the rails. So if I put this now in, let's quickly see. So the belt basically goes through the hole here. Then you can just pull all the belt through. And then you realize that this is the wrong side. So you do it again. This looks great so far. Thank you, GainV3. I hope it prints great as well in the end. That's yeah, I just mentioned like I'm still like doubtful. Oh, that was the right side. Oh, I put the belt in the wrong direction. The belt needs to go towards the hook. Sorry, needs to go towards the hook. So it needs to be this way. Okay. Yeah, this is the way. Okay, here we go. Make sure like maybe zoom a little bit out. So now the tricky part is a little bit like fiddle this in. But once this is in, like you can now basically pull this up and you see basically this just will tension the entire thing. Let's just put a screw in. It actually took me like quite a bit of like thinking to get this tensioning mechanism or like this like entire thing this compact, because I didn't want to like make this joint very big, because like every millimeter you have here in height is like height you lose from the Z travel. So I tried to make this basically as high as the bearing and not any higher, but still like have the tensioning mechanism here. Cool. Then this comes on, and then let's already put 2 of the rods here. Take the screws. It's 12 millimeter screws on the side. This is the way. I thought it when I was saying it, yeah. Unintentional pop culture reference. These we can already tension. Like, I was thinking like these 2 screws are completely useless. It's just like to make it, I only added them to make it like look the same as all the other parts, because they all had screws in this line. So I just added screws there. The part was actually staying like very nicely without the screws. I mean, it was a little bit loose here, but I could have also added like some hook where I just slide it in. But yeah, I just wanted it to be like, you know, like the same. Okay, then let's just put those parts in here. On the other side, we need to figure out a bit how one is quite a bit longer than the other. See my cutting skills in action. So yeah, that's basically like we need to kind of figure out how far back the other part needs to be. I added like quite a bit of wiggle room because the prototype parts were like the rods pushed the part too far back, and then like the belts weren't aligned. Okay, and I'm really interested. Like I'm a bit worried basically that you can later twist this a bit. Like all the things here, like the rods are on themselves not really like strong, like because they're round, it's so easy to like twist them. Yeah, so it's a bit of concern. Let's see. Yeah, this is the right part. I definitely need like a longer arm for the camera. And yeah, these parts are also like completely identical left and right. It's just like which side up. Okay, let's add screws here. Just to hold together, but then later we need to kind of adjust this. Yep. Are you going in? Why doesn't this want to go in? Oh, actually, I don't like this side being up. That's the side that was on the bed. I want the other part. Oh, it's the same? Wait. Did I print the same part twice? No. Me trying to figure out things that are very simple, actually. No, they are the same. It's twice, 2 times the same. Okay, well done. But most likely, these are like 2 parts, but I rotated them in different directions, resulting them in being the same. Yeah, why is this not going in there? Okay, you have to squeeze it a bit. Yeah, now we can kind of like slide this a little bit in and out to like later get this belt perfectly vertical. It's like an inbuilt swing. Let's also get these screws in here. Maybe it's easier to first put in these 2 screws. We can try on the other side. Oh, we shouldn't have assembled it yet. We forgot the slat. Let's see if we can get it in. So this goes in like that. And that means the belt is like this. Okay. Let's pull all the belt through. Yeah, easy. Easy. And now that we have it here, like this screw is also easier. Maybe you can actually just assemble this part like completely mid-air. Yeah, and like adding these 2 screws first will like make it much easier to have these 2 aligned. Now I can just push it in, hopefully. Oi. Oh, I think I didn't file off the edges of these. Which makes it a bit hard to push them. Let's try. This helped. Yeah. Okay. Cool. Okay, then that's one side. Let's belt it up, I guess, and see where I screwed up. Okay, let's do the back one first. So kind of have to get this below here. And it's the inner one. And then this goes over the top. And then goes in here. And now basically the goal is to get this level. I'm pretty sure there's something wrong with the file. This cannot be aligned. Like if you look here, I think I screwed up. Like these two bells should be on top of each other, but this one is too far in. I think there's too much distance here. See if I can like this a bit further in. Just trying to get the two bells parallel. I don't think it actually matters this much. This looks quite parallel to me. And then the other thing is like, I'm not quite sure if this is like something we need to see then, like from the side to side. Okay, that's one in. I'm not ending the zip tie yet in case we have to do it again. Then this one, basically same thing. So this goes under here and then back to the front. And then basically here is like two idlers. Oh, this one was experiment. There's a different one. Let's actually quickly undo that. I tried what happens, like I tried to route the back belt a bit different. So now I had like two idlers here, but you only need one. Could get rid of this. We only need one. So it's just M3x12 screw, one washer, then the two bearings, and then one more washer. Okay, clean up all the washers. Okay, let's put this back in. The internet went down when I was about to ask you if you have a rough estimate on your spendings. On this machine, I'm not quite sure, to be honest. So initially it started out as like super cheap. Just like a side. So basically this goes on the bottom on the way down. And then this goes on the upper one on the way up. And then it goes over the top and goes into the slit here. Like this. And now already this moves. Just have to tension the belts. Spendings. So basically, initially this was like meant as like a super cheap build, right? I'm not sure if you remember the beginning of the series, if you watched the series in the beginning. But we wanted to have like these teeny tiny steppers here, and the goal was to have all the hardware parts, excluding the prints, for under $100. But that's turned out to be impossible, and not from like that's not doable. It's just like the cheaper you make it, the harder it gets. I think. I tried to replace like standard parts with like self-made special parts, and yeah, that's just like way more difficult. So I pivoted to making all things kind of like standard in a certain sense, but keeping the rods as a frame. So I would say it depends a bit like what you have, right? The motors, for example, I already had. So the motors will be like, say, 30 euros. The belts and pulleys will be also, let's say, also around 30 euros, so 60. You need the smooth rods for the rods where the bearings are running on. Will be also like maybe 15, so like 75. The rest of the rods can all be from the hardware store. So this is all hardware store rods, the ones that are nothing is running on. It's like maybe 10. So it's like 85. You need the bearings. Let's say the bearings are like 5. So it's like 90. You need... What else do you need? You need a hot end assembly for tool head. Let's say this is another... Depends on the hot end, of course. But let's say like this is like 40 euros. This is 130. You need a main board that's 30, so it's 160. You need a power supply that's 20, so it's 180. You need a Raspberry if you want to count it, so it's like then 200. If a Raspberry Pi Zero is like 20, so 200. You need a heat bed. I think mine was like 30, so it's like 230. You need like the pulleys here and some other small parts. So I would say like another 30 just for like small things. Let's say another 50 for like small things, hard like the screws, heatset inserts, whatever. It's like 280. Yeah, so I would say like between 250 and 300 euros, depending what you have. And dollars will be a bit less, I guess. So maybe like $250. Something like this. Very, very rough estimate. How long have you been working on the build for? Quite a while, actually. Like, I think it started like March, February, March, something like that. You would need to check like when I started the build series, when the first episode was. But then basically in the middle, I kind of had like a little bit of like motivational down. Let's put it like that. It was basically after the XY entry was working. I thought like, yes, I'm there. Like it's so easy now. And then I realized how hard it is to make the Z. And then like I kind of was like a little bit like, yeah, demotivated. And yeah, now it took like another 1.5 months for me just like to pick up motivation, and now like 4 weeks ago I think I started again. For me it's also like it takes quite a lot of time to design the parts and like test print them and like try out what works, what not. It's not like that I'm printing like shitload of like prototype parts, but still like it takes time to design, iterate on the design. I think I had like 3 or 4 designs for this like corner piece here before I like ended up with this one. So it just takes time. That's why it's a little bit of a slow process, but I also think like you shouldn't, or I shouldn't rush it. It's about the fun in the end. So, did I do it wrong again? Yes, I did it wrong again. This one is also from the other side. Okay. Yeah, like for example, these small parts, right? Like it really took me like 3 hours of just like prototyping iterations and like trying out, maybe 2 hours to just get this like part right. A lot of things actually you design in, like, because I designed it in Fusion, it just works most of the time, like because you already see it quite well assembled in the 3D virtual world. Most of the things just you put it together and it works. Like I'm seldomly having the problem that, for example, I design something and it doesn't fit together. That's not really a thing, luckily. I should say. But yeah, still like takes a lot of time. That's also why I'm not working on this build every week on stream. I had the Ender as a filler, like the Ender wire. I somehow feel like I did a really poor job with the heatsink inserts this time. They're not 100% where they should be. So yeah, I always have like other filler projects basically, and this is like kind of like on the side a bit. Reason being that, yeah, it just takes time. And I'm also relatively busy outside of that, so I can't really spend like half a Sunday every week working on this. Oh. Okay. Let's leave the belt for when everything's kind of like together. And then let's do the last corner. Oh, wait. Wrong way. Here we go. Got to get those, keep those octave views happy. Yeah, exactly. That actually takes quite some time. No, it's also like, I mean, on the weekend, I'm usually like doing non-printer related things, Saturday, Sunday. That's also, I think, important to have some other hobbies besides that. And then, yeah, it's just like, usually Sunday, I'm not home at all. Saturday, I kind of have to do some chores and stuff as well. No, it's tough life. And then during the week, I'm yeah, coming home also like after work, and I'm not really in the mood of like sitting another couple hours for the computer designing parts. Like SD card support, exactly like SD card support. But funny enough, like I think like once every year somebody's asking for SD card support. Like it's really not like, I don't feel like it's like a feature a lot of people use. And at this point, I mean, maybe your Bamboo Lab plugin completely like explodes and becomes like the hot new thing. Then I will add it, of course. But like, I learned by now that if I add things like SD card support, it will break. At some point, it will break. Something happens and then it doesn't work. And then you have to fix it. So it's not only that you like spend effort on like implementing this thing in the first place, right? It's also like it breaks and then you have to fix it. Okay, let me quickly file off the ends of these as well. I feel like they're really sharp and making it hard to push into the plastic. You don't have to tell me that I do have 50 plugins with people wanting enhancements. Yeah, exactly. And for me personally, it's like really hard sometimes to say no. So I'm kind of like like not bullied, but like convinced into doing some stuff sometimes. And it was really like a learning for me over the last couple of years where I did OctoApp. It's also okay to just say no to random people who want something from you. Let's get this in. That's also, I think it's smart to do the belts when it's completely on the bottom, because then you have a little bit of like a reference back and like on both ends, how high, or like at which, oh, there's no pulley yet. There's no pulley. Something is missing. Hi there, 3D experiments. It's here. Is there a cat view for this printer? We can look at it. It's not published yet, and I don't have Fusion open. But I can open Fusion for you. Okay, so now the belt goes up here. But the Fusion files are pretty much what you see on camera, because I designed the printer basically as I go. So there's not a lot more. Oh, it's on the wrong. Okay, now it's in. And then, oh, there's also no pulleys in front. See, now I opened Fusion and it's okay. Oh, because I pressed 4. My bad. My bad. Give that a second to recover. Okay, there's also no pulleys in front. So we completely missed this side. Did I kill the stream by opening Fusion? I think something bad happened. Okay, seemingly something made YouTube very unhappy with my Fusion. Maybe somebody in the chat can tell me if the stream is... It's back now, okay. So I tried to open Fusion and something completely got toasted. So I will not try that again. So 3 experiments, I'm really sorry, but there is no cat view at the moment available. Not quite sure what happened there. Okay, that's number 1. And very unfocused number 2. Okay. Back, then it focuses on the center here again. So this goes here. Then through here. Back to the front. Not twist our belt, ideally. Okay. It goes up, around, and into here. Cool. Now we have 1 and 2. I mean, the belt tension is not very good, so maybe we should actually try to get like 1 more tooth out. So the question is like, how do you I mean, we have enough tensioning range to like compensate like the belts being different lengths slightly. Could be not a problem. And then here also it's the same thing now. We kind of need to adjust the distance here. Ugh, that's really tough to push. Let's actually tighten the front. I don't want to slide out there. And there's still the stupid sticker I couldn't get off. Like the rods are kind of temporary. So some of them are hollow and some are solid. And I want to get rid of all the hollow ones. But they're only sold in one hardware store here. And I didn't have the chance yet to check them out. Yeah, I definitely think like these parts are... Oh! Shoot. That explains a lot. I think they're not... The belts are not properly lined. Oh, they are. No, they're not. The bottom slit here is not centered to the rest of the belt. That explains why they're like pulled in a little bit. Yeah. So I think if I move this to the center, you see it more clearly. So, not quite sure if you can see it actually. So if I align this, that like the top belts are the same, you see the bottom belt kind of peeks out here. Like this is not aligned properly. Now Fusion would be really handy to verify that. But it's definitely wrong. Let me quickly... Let's try the Fusion thingy one more time. So I have to go now and enjoy my birthday. Happy Paul birthday. Happy birthday, Paul. Happy birthday, Paul. And let's come up with the Bamboo X1 community. No concern of using smooth idlers versus toothed idlers for the VFA. I'm actually not quite sure. I copied the idlers from the V0. That was kind of like part of my idea was just like to copy things that I know work. So potentially I read that toothed idlers are better, but I just copied what was available, like what was working. I do have VFAs though on the V0, so potentially there's the link. Yeah, so I'll try this Fusion thing again. Let's see what happens. Now it seems like Fusion wants to open. That's a good sign. It's preparing our experience. It's open. Okay, let me quickly set this up. Okay, quickly have to put this where it belongs. It's always a little bit of pain with Fusion. Here we go. Here we go. Okay, so 3D experiments. Here's your view. Your 3D cut. I have the support parts are always red, but yeah, it's already I can tell like this is not where it's supposed to be. You see here's the top corner. So if we do like section, on this surface here. You see like how much this is off. Wait. Fusion not happy anymore. I hope now the stream is still fine. Fusion is not happy. Okay, enough Fusion for today. Like something is not okay with that. Oh no, okay. Similarly, it's happy again. So if I put this here, so this is definitely not aligned. So you see this is now basically the side of the bottom belt, and the top belt is like a solid millimeter or a little bit more off to the side. And that's, I think, the vertical issue we see. So that's a bug in the part, so I will have to reprint that, which is the biggest part in the entire thing. So I'm very happy that I have to reprint that. But it definitely needs to be fixed because now the belts are pulled to the side, and that's not good. Not good. It's sad, so it's less not good, but still like not good. Okay. Then, so that's basically how far I had it prototyped. Now we are entering uncharted territory. So how this now works is we have quickly sort this. That's for next step. No. Oh no. I didn't print enough of those parts. We would need 2 of those and 2 of those. Oh. Okay, what a bummer. Like 4 and 4, not 2 and 2. It was such a pile of parts, I didn't notice. Okay, let's fix that. Let me quickly start a print with that. Let me quickly start a print with that. Welcome to a normal stream. Yes, I know. I know. What would be a stream of mine without some chaos, right? Okay. Let's do the following. I quickly print the parts. It's 1 hour of time. I'll just print them all in black in one go, then we don't have to wait. Okay, how long does it take? 1 hour 42 minutes. That's not quite acceptable, right? 1 hour 42 minutes is not acceptable. Let's see. We can go to prototyping. Discard. 1 hour 13 minutes. Let's do another hack. Let's do layer height. Let's make the parts a bit weaker. So less that, less of that, less of that. Okay, okay, 1 hour 13 minutes it is. So with heat up and everything, 1.5 hours. Shit. Okay, it's printing. Sorry for that. So let's do the following. Let's assemble these. that we connect the two halves. And then what we can do is we can work on the electronics. So we can flash Clipper to the board because my goal was to move the bed today. So we need a main board that can do that. And the main board we use so far only has 2 steppers left. So that's not enough. So let's just flash the main board we want to use there. And get started this way. Then basically we just bridge the time until those parts are ready, and then we put everything together. And at that time we can already move it. So hey, that's good. Yes. So here I mentioned before, like the first layer is really off with those turquoise parts. So we kind of need to read that here. Basically, this is like a clamp. That clamps the rods. Maybe adding a chamfer here would be good, that like this doesn't happen, even if you have like a bad first layer. Okay. Cool. Then we need 4 heatsink inserts in those parts. But yeah, Steve, you're right. It's always the same with my streams, right? A little bit of chaos is needed. What we can also do technically, if we don't want to do the electronics, but I think electronics makes a lot of sense. Otherwise, we can put together the tool head that's also ready to go. And if we are too fast with electronics, we can do actually both. So, but let me close Fusion. I don't trust Fusion today. Like, it's doing so much weird stuff, so I don't want to have this open. Don't save. Okay. Okay, that's it with heatsink inserts already. And we can, let's also do those parts already. So these are like the clips that hold the bed layer. These don't need. These 3 need. And I think we are pretty much done then with heatsink inserts. Oh, also yeah, let's just finish heatsink inserts. We're using a lot of inserts today. You're printing all these parts in ABS. Yes. The black ones are Form Futura Titan X ABS. And the turquoise teal color ones are Polymaker ABS. But I'm not really happy with the Polymaker, to be honest. That's the first time I got Polymaker ABS. And it might be my print settings, but doesn't print super nice for me. The Form Futura is way easier to print. So it's most likely after the prototyping phase, I will drop this color and use something else. I also kind of low-key run out of this color, and I definitely don't want to buy more of it. So we might see a little bit more black in the future. In the beginning, I also tried to print some parts in PLA, but that was just not a thing. Like especially with where the rods like are clamped, like the PLA parts just completely fell apart. Okay, let's see if this works. So basically the idea is to have this clamp like this here, and then have rods going across. Oh, let's also quickly file those. Same. Yeah, and that's why I mentioned like some are hollow, some are solid, and the hollow ones will all go. Now I switch to the solid ones. The solid ones are actually cheaper for some reason. Yep. Uh-oh. Oops. Remember when I said I didn't prototype these parts? I think they need some extra spacing there. Let's see if we can get this to work. Oh, we forgot the heat sensors here. My bad. Let's also keep an eye on the V0. Which already screws up. That's good. Maybe not screw up, but it has like a lot of gunk on the nozzle. Let me quickly fix this. 1 second, I'm right back. Looks actually quite okay. I'll continue the print. Oh, but now I see there's like a lot of like filament hanging out. Yeah, we'll be fine. As you see, the parts are not good anyway, so we will like replace them. I'll just print this now that we can build. Oh, turned off the soldering iron. Let's see. Does it fit? I mean, at least it fits here, which is quite good. So let's see. Yeah, I printed the parts yesterday and I didn't really have time to like do like a test with them because I also didn't have the other side built. So yeah, as mentioned, now it's uncharted territory. Even if we don't get the bed mounted, at least we can like test all the mechanics. Yeah, I think there just needs like a little bit more spacing, that the rods don't push the parts out as much. First layer looks okay. Okay, so let's try this again. So this side is already tightened. Oh, no, it's correct. So now the question is just like, how much do we need to push this apart? So that's like one of the challenges in this print is basically because I know I'm very bad with cutting the rods to size. I always design the parts to have like a little bit wiggle room and lengthwise from the rods. But what this then basically means is that you need to be very certain like how far the parts should be apart. So I think what you need for this build is like one reference rod with like 2 parts on each side where you can put it in to like copy the width of different sections, right? Because like these rods, like the vertical rods here, these, they should all be the same width. So you can, on the top, basically the gantry sets this width. But then basically what you can do is you can take this rod with your copy tool, basically, copy the width, and then you can just put it here and apply the same distance. So at some point, which might be like next stream actually, we need to like have this copy tool and then like go through entire frame to make sure everything is square and has the same distance to each other. Because now it's just like feel. It would be nice to have a little bit more than feel. It's also like later, if it's not square, the printed parts will not be square. So I think this is kind of okay width-wise. Oh, actually that's too tight. Okay, maybe that's a good idea. We can copy it from the front. Let me just loosen this, and then this is now kind of like adjusted width-wise. Let's tighten, or not tighten, but like assemble left and right. Oh, and there I forgot support for the holes. It's something I sometimes forget. Let's add it from the side. And then the other side, and then, I mean, at least it's linked. Force the screws now in a bit because of the mess of the unsupported holes. Okay. Well, it's actually quite good. We can now like connect them here, more or less. And then we have now like quite a good idea of the width, because this is now like more or less like in a right angle here, because it's the same distance left and right. Let's tighten this here. And I think actually these parts are quite okay. They need a little bit more spacing vertically for these two rods, that like it doesn't make this crazy sounds in the beginning when you push it in, but besides that, it should be fine. And now we can just slide this back, and then it should be like, I don't know, like somewhere here. We need to like later position this exactly. Oh, by the way, I had like the crazy idea, Steve, because you asked about the ABS. So I think the skirts we can safely print in PLA, because the skirts are just like clipped on basically. I kind of had the idea it would be really cool if this printer prints its own skirts. If we get this to work at some point. Let me actually just use this as a spacer. The exact position we will later need to figure out. But they need to be like at the same distance basically for it to be square. And then we can also, we didn't tighten these screws here. I mean, this looks okay with the caveat that the belt is definitely not aligned. Okay, that's not all tight. And this side, oh, we didn't even add screws here. It's also good. Also here, like, I mean, this will never be 100% aligned right now, so let's just put in screws. And this already feels a lot more sturdy with the single bar in here, to be honest. This feels already pretty sturdy now. I can wiggle the entire table. Now, technically, like if we, let me turn this over like this. So that counts. So now, I mean, the problem is not like you can really like bring it out of trim by like only rotating one motor, of course. But the idea is that like the end stop being here and on both, like we have end stops on both sides, which we should actually like now mount, that we can like level it out by like homing against both end stops. Okay, let's steal the end stops. As mentioned in the beginning, I don't have enough end stops. So I only have 2. I ordered more, but for now, let's just steal the X end stop from here. To show you, it's like, oop, kind of like hidden underneath here. So we can just quickly take this. You can try to take this. And transfer that down here. And the other one is here. It's just clipped on. Okay, so let's see if I can kind of like aim through here. Thought the accent stuff was faulty. Yes, there was the ender wire, but I actually ordered new ones. But I'm actually, like, by now, I'm not sure if I want the accent stop there anymore, to be honest. Because I was printing my boxes. I think I mentioned like a million times now, I print these like storage boxes. And the accent stop steals me like around 1 to 2 millimeters of X distance. And this 1 to 2 millimeters causes me to be almost unable to print the boxes. Every millimeter is needed there. So here we now have the end stop, and if I move this down, I think it should should click. Very nice. Let's put the other one. I think it's actually quite a good spot for the end stops, to be honest. I'm not sure in the end if we need them, because we will use the probe eventually. But for the time being, I think it's quite a good solution, because, Steve, not sure if you recall, but I asked you about your opinion on sensorless homing on Z to basically ram both of those just in the base to ensure that the bed is tram. But I think the two end stops is a very good solution. That was this part, yeah, exactly. And I also, not sure, I'm pretty sure you saw it, but like I incorporated your feedback here, right, with the zip ties. The zip tie lock that goes through here. And now this is like, if you close the zip tie, this belt can't get out anymore. So it's actually quite a good solution, I think. You can just pull it through, and now you can pull it. Oh, oops! Now it's blocked. Okay, well. Now we have a yellow zip tie. Okay, yeah, like let's do the mainboard. I just have to remember where I put the mainboard. I think it's over there. Let me quickly grab the mainboard, and then let's flash clipper on that bad boy. And then we should have X, Y, Z. I'm not sure if we want to do the belt tension already. We can also do the belt tension. Let's quickly tension the belts. Let's quickly tension the belts. I really love this belt tension meter, by the way. Let's just figure some tension out. I think around 2 is fine. Let's just do 2.1 or something. So we can... The distance should be 15 centimeters, but I think it's fine if we just like do it now here when the switch clicks. And then let's do... Show this closer. So now it's 2. Does this work? No, it's 2.2. Okay, so this is 2.2. I think that's quite a good tension. Maybe even a tad too high. Let's go for yeah. Let's do 2.2. Let's see what 2.2 does. Let's just do 2.2 on all 4. And luckily, that's really easy to reach, unlike the switch wire. I always find it a little bit tricky. Oh, here's only 1.5. So maybe we can try to pull one more tooth here. Oh, now it's already 2.2. Okay, interesting. 2.1. Almost 2.2. So really little tension here. Now it's 2.2. Okay. I think belt tension meter for this machine is really must with the 4 belts. Otherwise, you really like in a tough spot getting this all the same. Wait. Yeah, same here. It's like 1.5. Let's try to pull one more tooth here. Now we just need to tension a tiny bit. Oh. Okay, 2.2. And the last one on the back. It's also at 1.5, so let's try to pull one more tooth here as well. Oh, but now we are already at 2.6. So let's rather do the lower number and we can tighten. 2, 2.1. Oh. Something snapped somewhere, and now we went down to 1.8. So now let's just release the tension again. No, you don't see anything, right? Very sorry. Let's try to do one more tooth again. Yeah, okay. So somewhere down here the belt wasn't quite aligned. Okay, here we are at 2.2. Just double check. Yeah, now we changed the front a little bit. Now the front is 2.2. Also check this side again. Yeah, it is now way too high for some reason. So I think like the belts influence each other quite a bit. Wait. Yeah, every time I get now different measurement. Yeah, now it's also like 0.1 higher than. That's weird. Not quite sure what I'm supposed to do with that. Let's quickly check if the calibration is fine. Yeah, 1.9, so that's nice. Weird. Why is it then so difficult here? Oh, I think I really have to pay attention. It's like straight on. I think it's really easy to like have it like a little bit like tilted backward, and then it measures differently. But now it's also, that's annoying. Okay. It's around where it should be. I never had this much issue with this device. Okay, it's around 2.2. Let's just accept this. This is now like way above, if I believe this. Oh, probably on. Maybe that's quite a good way of getting it to settle. Pulling on the belt. That's 2.2. Let's try this on the back. Wait. Yeah, I think that's quite a good way. This way it kind of settles quite okay. Try the other side quickly again. It's quite okay. Now here, like I'm twisting and nothing really changes. Now it's 2.2. And last but not least, also way too high now. Oh, I think the problem is that we are not measuring the section we are tensioning. That is the problem. We need to tension this like while it's all the way on top. And then we need to tension this belt here, because this is the one we are tensioning. It might also be a problem. So basically this belt section here is like super loose now. That's like super loose, and this one is very tight. Not sure if you can see that, but like here's kind of the same, here's kind of the same. So I think We kind of need to like get one tooth from this side to this side. Oh. Okay, I thought this was not possible. Seemingly this is possible. Let's quickly check what happened there. So the tensioning is quite challenging. Part looks okay, so really just like pulled out. Yeah, seemingly my tension mechanism is not as good as I thought. Let's make sure that like there's enough tension here. That's a bit of a problem. Like I'm not quite sure why. I mean, I understand what the problem is, I think. Because we're tensioning one side. We're tensioning like one side of this like system here, right? And like the tooth of the pulley on the bottom prevent it from rotating. So maybe it's also stupid, but maybe like if you undo the pulleys while tensioning, you know, like the pulley can kind of adjust. I think now it's also much better tension-wise. So maybe it was just like off. Again, like this side is most likely much higher tension. Yeah, this one is like almost 3 on this side. And here it's like 2. So it's like the tension between these two halves is completely different. I think my tension mechanism is not good. But I don't understand why. I mean, for now, I think it's fine. But potentially we have to revisit that in the future. I also now see that this is not quite, like this should have been a little bit more back. You see like the belts kind of run apart a bit. Yeah. That's it for now. I think it's fine. Like we need to go through and like tune everything anyways. For now, this kind of works. This button doesn't click. Oh. So basically, how do I show you? This is not quite on the bottom yet. So basically, this is now one tooth off. Ah, now it's fine. Okay, I just pulled a bit more and now it kind of like self-adjusted. Okay. But if you see here, on this side, there's like quite a healthy gap, like the same gap as on the back. And here it's completely closed. So this is now one tooth off after our reattach cycle. So I think what we should do is like we should like lower this like one tooth here. I'll do it like this. It's still not good. Yeah, I kind of thought this will be a challenge to get straight. And yes, it will be a challenge to get straight. I mean, you can always like use the bed to level it out. But now it kind of looks okay. I mean, at least as long as if it's consistent. I see here, like on this side, there's like a very nice even distance front back. And here it's definitely more distance on the back than on the front. So maybe we need like one more tooth. No, now it's even worse. So to make this lower, we have to pull one tooth this direction. Yeah, now it's good. Or at least better. Let's do one more tooth. You will need to loosen the pulleys. The Ender 5S1 does the same thing when you adjust the belts for X. Also, you have to loosen the pulleys. But then the problem is like, because you kind of want to have the pulleys on the flat side, right, of the rod, of this like rod here. Yeah, but I think like that's the only way, right? You have to loosen the pulleys. Yeah. For now it's okay. Like we can test with that. But it's something for later to figure out. I mean it's a bed, it moves. Just like for testing purposes. So there later will be this clip here. Pretty much in the center, ideally. And this is what holds the bed. So there will be one in the back and two in the front. Let's actually do this from the side. Let's be smart. Yeah, that's what I feared. Like this is like twisting a little bit. So that's not, that's this with those rods, like maybe it's better if we use two of the solid ones because they don't flex as much. But that's the problem. Like now, this is not stable enough. So basically, the idea is for the bed. I mean, to be honest, like if you have 3 of them, maybe it's better because like basically you would need to twist all 3 at the same time. But basically the spring comes here, goes there. And then wait, I quickly have to grab one of those screws. The screw goes through the side that you can see. And then this spinning thingy comes from the back. And I think the screws are a tad too short. Oh, and there should be like a washer in between. Otherwise, it's really hard to spin, which actually might be good. Let's not put a washer. Okay, this is hard. I think longer screws are required. Wait, okay, I have it. So that's basically then the mechanism here to like change the bed. And ooh, it touches here in the back. That's not good. That's not what I saw in Fusion. Yeah, this doesn't work. There's a problem. That worked in Fusion. Okay, so that's a problem. So the bed needs to be higher to like clear those parts here. Oh, it's a bummer. I mean, the problem is I can't really move it forward because there's quite a lot of like depth to it. Hi there, third MFN LVST. Hey there. I sent an email with some feedback for Octo. Cool, like I'll get to it tomorrow, I guess. I always check in the morning the emails. Yeah, that's a bummer. I think in Fusion this back part here was like way smaller. That's why I didn't have the collision there. Okay, but nevertheless, it's a very badly mounted bed. And it's moving. So hey, that's something. Oh, but also like this should be quite a bit more forward, I think. Because like now if we kind of move this to the front, let's just move this all the way up. Oh, it also collides with the motor mount. Amazing. Yeah, this can go a little bit more forward, but hey, it's still like lights also here. Let's move it forward. But also can't go like too much forward because we are already kind of now at the front edge of the bed with the tool head. Let me just push this a bit forward here. Just take that, and then you can always tighten the screw on the side. Now you can use it to copy on the other. Okay. Tightening this side. Tighten that side. Okay, so now it at least clears the back here. So that's not clear, like not clear, but like kind of okay. But still, like this part here is still in the way. Can you mount the bed from the 4 corner mounts and do away with the extra rods? Redesign the belt mounts so also hold the bed in place. I thought about that. The idea why I have this, like these like horizontal rods, is that firstly it makes the bed frame more sturdy a bit. That was the idea. Because I cannot, right? Like because we only have 2 motors, so we can't do really like quad gantry level thing like the V2.4, for example. So I still need the springs. Because we only have 2 motors. Like if you would have like 3 or 4 motors, we could like directly mount them to that. But we still need the springs. And then the idea was that this just gives like more sturdiness to it. I mean, technically what we could do but technically I think you could do it. The idea was just basically that this allows us to have the springs easier. And then also this design allows for basically any bed to be mounted, right? So now we use the Prusa mini bed. But the idea was that you can scale this design up and down a bit. That basically you can also use a V0 bed or like an Ender 3 bed, something like that. And then this design just allows you to have like random connection points to the bed. So you don't necessarily need the 4-pin, the 4-point, but you can also use 3-point beds and yeah. But nevertheless, something needs to be redesigned here. And the easy solution now would be to just flip the bed mount around. Because this now like lowers it down a bit. And we are not like, we don't need a lot of clearance here. So technically we can just, and that's not really how it's designed because like the screws need to be on the bottom. Otherwise you can't adjust the position of this clip here. But for demonstration purposes, if you flip this over, like wiggle this in a bit. Oh, no, it's most definitely not center. Can't you mount the bed from... Oh yeah, wait. You would have 4 springs. Yeah, I mean, yes. I know what you mean, Steve. I mean, technically, yes, we can get rid of those. I can design those like blue parts here to have the mount here, right? In this area, we can have the mount. Or like this black part comes out further to have the mount. But then, yeah, I'm really like boxed into like this specific bed. Then I'm definitely boxed into this specific bed. But nevertheless, how we mount it, let's just first try if we can somehow get it physically fit in there, right? Trying to center that roughly. Smart people would use math to calculate. I'm just wiggling back and forth until it fits, but I think this is roughly center. Yeah, I think, Steve, yeah, that would be the best approach. I would still need those. But like this, it would fit in, at least. Let me quickly grab an M3 nut to kind of like... Actually, we can also use this. Quickly secure that. Oh no, needs to be nut. Okay, success. It's a bad. But even now, it still collides with this end piece here. So this needs to be significantly higher up. Only having one spring on the back will have both back corners moving to easier in probing and printing. Now, I'm back. That's a bug of OBS, I think. Let me quickly sort everything. Ah, now this... I hate OBS sometimes. Okay, you don't have music anymore. I can't change this. The property thingies doesn't open anymore. Ah, here we go. Okay, we are back. Sorry for that. Okay. Steve, can you confirm everything is back? I think everything should be where it is supposed to be now. Where were we? Springs. So I think one spring is fine because like usually you have like 3 points for the bed, right? And if the front parts are not like this, oh, would rather have no music and listen to the same tune all the time. Okay, feedback received. I can turn off the music. I will change it up for next time. Let's see. So basically, if we have 2 front parts, it should be fine. The problem is just like that this is completely colliding with this part here. So we can either move the bed quite a bit up, at which point we lose just Z, which I guess is kind of fine. The other option is, to be honest, maybe we can make this slimmer. Because now it's no problem. So maybe we just need to like redesign this part here to be like less intrusive. Because now like there's tons of room. I think that's the way to go. And these are the parts that Prusa designed basically. And they're quite big actually, I think. I'm pretty sure we can like slim this down quite a bit without losing the functionality of it. You still have to compress the spring all the way down to adjust. Well, not all the way, right? Like, I mean, depends how much like you want to adjust, right? The spring has 20 millimeters maximum. So if you want to adjust 20 millimeters, yes, you have to tighten. But I think now you have quite a lot of room. I mean, you can adjust quite a bit down now. Still not ideal. What do we do there? So, I mean, the problem is we cannot really slim down these parts here because the belt tensioning is there. It doesn't need a lot, like a couple millimeters. I know, for the scream, no worries. Prusa mini heat bed, yeah, exactly, Prusa mini heat bed. Don't slim the top down, it will melt. Yeah, that's the other part, right? Like if you get too close here, you might get problems. Maybe if you use the rubber and not springs, that then you can get for ends. I actually have them here somewhere. But I don't think they will change a lot from how the bed is positioned. I mean, maybe we can actually move it a little bit further forward still. Because now it's pretty much on the front side of the bed now. So this is kind of like as forward as we can go without losing build volume. Yeah, but it doesn't really help. So we need to redesign these parts here to be like a little bit less wide. Potentially what we can do is at the moment, the tensioning mechanism is on the outside of the belt, right? The belt is here and the tensioning is here. Maybe we can swap that the tensioning is on this side inward here, like basically here. then we can cut off like quite a chunk here of the part. And then I think what I would do, because Steve, I kind of like your idea of having the corners like mounted directly here. And like now it's already quite sturdy with just like one of those connections left to right. So what I would do, I think, like I would actually spend time and redesign this a bit. Let me get this quickly out of here. So what I would do is I would redesign these two parts here. You still need that for the belt to mount. Yeah, Steve, you yes, I need that, but I mean, look where the belt is here, right? So basically I can shorten this quite a bit. Like I can shorten that if I move the screw to the other side. I can maybe get 10 millimeters on both sides, and with 10 millimeters on both sides, I think we have enough space here, right? Because like it's not overlapping by a lot. Right? So basically if we get like half the screw, it's fine. The other option is just like if we mount it a little bit higher, right? That's also an option if we just like mount it up. Then we just lose like 30, 40 millimeters of that height, which sucks, but would not be at the end of the world. Why is this not in the center? If this would be here in the center, like this would be really, really cool. There's really lot overlap, right? I love hard silicone mounts on my CR10. I tried them on my Switchwire, but I didn't really like them. Like it was a bit hard to get it level. They kind of gave up on that. Yeah, I think like the only way is really like to move the screw over here, because there's like quite a lot of space in the part, and we can also like make it a little bit bigger here. So I would like move that tensioning mechanism from here to here. By the way, then we also don't need the parts that I'm not printing anymore. I'll finish them now because they're almost done, but then they're obsolete. So the tensioning mechanism moves out, and then we add... It's not a question, do we need this connection left to right at all, or can we get rid of that? Because maybe we can also just completely remove this like left to right connection here. Bit higher is an option, or maybe even turning the heat bit by 90 degrees. Turning by 90 degrees could also be an option, actually. That's a creative solution. I mean, ideally, I don't want to have a 4-corner mount. I really want to have my 3-corner mount. So what I'm thinking is to have the front corner here, like mounted directly here. Like we can expand this part here to just have like something coming inward and then having the mount here. Like that can be super simple. That's not a big deal. We don't have to work a lot on those two parts. For those two, I'm thinking, what happens if we do this? just connect them here, like shorter, like these are 20. Like if we do them 50 millimeters, like those are also 20. But like if we connect it here, just in the back, and then have basically this mount here like this to hold the bat in the back, then we have like a U shape to connect it. But because like this is, I want them to be connected. I want them to be connected here because like here they can twist really easily. Here they cannot because they're like on the rods here, but here they can. So I think yeah, these two should be connected in some way. So we can either do it with this construction that we already have, or with a new construction. But this can technically also be just in the middle then. Let me connect it back up. Couldn't you make parts for the 4 corner screws? Okay, I mean the 4 corners also like I really want to have a 3 level mount because it's easier to trim the bat. That's why I prefer the 3. But yeah, technically it can be 4 corner mount. Not a hill I'm dying on. So we can also make this like a 4 corner mount. But then we still have this like left to right connection. I think that's quite important for me. Because you see now like this is like much more stable here. Still like a little bit of twist, but way less. I think actually like the best stability wise would be if those two, like if this is not a separate part, but this is directly integrated into those corner pieces, because then they cannot twist at all. Then there's just like sturdy. I think that's the best way. So basically, yeah, these need to move out that we can make these a little bit slimmer. And Neo, then yes, the heat bed will be relatively close to those parts, but I think it will be fine. Because it's ABS. And the heat bed will be realistically max 100 degrees. Should be fine. Yeah, so we move those over, and then we will add mounts here to like connect the two sides. So instead of having this like shape here, they will just go directly connecting. And then what I would do now is I would just put the heat bed on top. Then we lose 20 millimeters, 30 millimeters of height, but I don't care. Nevertheless, when we do that, the issue persists with the motor mount here. If I quickly put this back together, so I think we need to replace this part either way. This doesn't want to come together. Okay, so I think we have to replace this part either way, because this hits here. But what we can do is we can replace this part with a part that guides out the the cables in this direction here. That basically the cables go towards the center, right? Now I take it off again. I was like very sensible of putting this on. Because like we can guide the cables more towards the inside. Just have to pay a bit of attention that we don't short anything, but like if we route this more towards the inside, still a bit tricky. But what we could do, not sure if that's a good idea or not. It's most likely a bad idea. Yeah, it's a bad idea because the pads are on top. There's no connection. I was thinking to move like the ground pin to the bottom and then have it come out to the side directly. Because if we do it like this, like we can do it, put it here. And it's just like the problem is there's like this like diode that I don't want to. This also should be fine. Yeah, you can kind of do it like this. That should not short anything. And now you can like guide it to the side. And then this entire problem is not a problem anymore because then you have tons of space. Oh, wrong way. Right? That would be like a good solution. Then this doesn't matter anymore. Now we just sit it like, I don't know, like this height here. Push a mini low profile heat back cover with 55-degree angle and make M screw for Z axis more flexible. Let me search that. So you mean like somebody already did all the work for us? Pusha Mini 55. Yep, this. But I would do it even more, to be honest. I would do it even more. I mean, 50, like, looking at this, it's kind of like, it would be enough. Would be enough. Maybe we need to make it a little bit more compact even. Because on the bottom, we don't have like tons of space then. Okay. Oh, that's annoying. I thought that would fit better. But hey, step by step to the end, right? So I'll post a link, but I don't know if you allowed it. You can post links. I think YouTube doesn't allow that. Okay, so what do we do? I think let me actually grab the main board and then we flash Clipper. And we have that ready. Yeah, we cannot mount the bed today, but maybe we can still like make it move in X, Y, Z. That would be quite cool. Yeah, let's do that. Let me quickly grab the board and then we flash some Clipper. Right back. Okay. Briefly showed last time, so this is the board we're gonna use. And it's always the little thing to take up the most time, yeah. A bit annoyed now that we printed those parts just now that we don't need. Like, yeah, technically I can cancel it. Yeah. Well, now it's 97%. Okay, whatever. Okay, so that's the board. We don't need the connectors now. And that's the pie. All very small. That's kind of like the goal. So then I hope we can power this from USB for now. We need to check the manual. There's like a jumper which looks very much like a USB power jumper. And we can connect this. Oh. And then we need to connect the Pi. Let me see if I have a cable handy. Here we go. So power this up and see if the board does something. Oh, it does something. Okay, so it gets USB power. Cool. Pi also does something. Let me actually quickly reduce the chaos a little bit here. That's something we still need to keep. Yay, the useless prints already. Okay, that's something we need to keep. Let me get rid of some tools. But yeah, overall, like I'm quite happy with the bed system now. It's just like we kind of need to like hash out the problems, but besides that, like, you know, it moves up and down. Hopefully under its own power very soon. And also then these bed clips, like I'm printed like a lot of parts now that I didn't need. It's a bit annoying. Because I'm kind of running low on the teal filament. It kind of hurts to like reprint a lot of parts through. I was quite confident that those parts are the final ones, so I printed them in color. I should not have done that. Okay, so that's trash. I don't have my little trash bin here. It's a bit annoying. Need to remember to put it back. Here. Okay. At least I can when my pickability cable broke, 2 connectors ripped off. On the V0, I had the exact same thing. What is that? Blue light, and what does it? Light is blue. That's all it does for now. um, Let me quickly... Quickly. Oh. This one. Here we go. Cool. How to be called that? Main sale.local, I think, right? I'll actually see if I can find it. We had the same trouble last time. I'll quickly check my router where it is. No, I don't see the... I don't see the pie. Let's quickly unplug that. Oh. I don't see like LED on the pie. There's usually like the green LED here, right? On the Pi Zero, I don't see that. Let's unplug the hat. That worked last week. Didn't do anything with it. I think that's a fried pie. But seriously, like, we used it, right? 2 weeks ago. There should be like LD here. There's no LD. Um. Well, that sucks. Rip. Rest in peace, pie. Well, we don't know what did not just break because you plugged the board and no cannot, right? Maybe we should have like, I mean, no clue how. I mean, you got it out of box. I put it in 2 weeks ago. And it's gone. I have a different one. Let me grab a different one. 1 second. Second one. Does it smell burnt? No. Doesn't smell burnt. Let's try this one. Let me just transfer the SD card. Also no LD. Okay, let me try a different power supply. The SD card was all the way in, I think. SD card's all the way in. Let me try some other power supply. Yeah. I don't have something handy right now. Let me quickly go under the table. 1 second. No, like also with the power supply under the table, like it doesn't turn on. But I'm just confused because like both of them are not doing anything. Why would it power the MC? Like, I'm pretty sure there's power. I'm fairly certain there's power. But there's like, this one has no LD and this one has no LD. I have a third one. Let me grab a third pi. All good things are 3, right? Third pi. This one even with case. Let me plug this into the MacBook here. Just to confirm. Yeah, this one has a green LD. Success. There's like, I'm not sure if you can see it, but like somewhere there. Green LD. So we confirmed they have green LDs. And yeah, the wrong port doesn't matter, Steve. Both of them can take power. This one has data, this one does not. But yeah, this one does not have the LD. Try this one. Awesome. I mean, maybe both are broken. I have no clue. Let's try this one. This one works on this power supply. So those two are toast. I don't know. Really weird. I mean, it didn't treat it bad in any way, like not particularly well, but like normal. I think I'm just cursed this week. I'm just cursed. I think there's some like poltergeist here or something. My speaker broke for my TV. I had like this external speaker, like JBL speaker that I kind of hooked up to my TV for sound that just broke. Like I was just watching something and like just mid-sentence it turned off and that was it. Like no power anymore, no LEDs, nothing, just that. That was Monday. Yesterday evening, my Wi-Fi access point just went offline and came never online again. Power issue as well, like no LEDs, nothing. Now I have 2 Pis. I think like I'm haunted. Gremlins. Gremlins. I have gremlins here. Mass frying pies. Well, Neo, I had this 1 week in my life where I killed I killed 3 pies, I think. 3 or 4 was a very bad week. And that was like just in the beginning of COVID, before I realized how fucking expensive pies suddenly were. So I basically fried like 400 euro worth of pies in 1 week, which was not a good week. Not a good week. Yeah, but I don't know what to do with those 2. We can take this one apart and use it. Do you have problems with your electricity at home? Not that you get some power spikes and damage your stuff. I have no clue. Like, I never had issues until now, and I'm living here since 6 years. The electricity in the house is definitely not, like, electrical systems in this house are definitely not the most modern. Look at this power outlet. And the trained eye will see there are exactly 2 pins, and there's no protective earth. That should tell you all you should know about the electrical systems in this house. I only have a protective earth in the kitchen and in the bathroom, but nowhere else. Everything else is those 2-pin outlets, which is super sketchy. I would say that your house is like 50 years old. 50 years is pretty spot on. It's from 70, 75, 73, 75 or something. But trust me, it looks a lot older. It looks a lot older. It's like in the city center, more or less, of Amsterdam. And it's built to look like the really old canal houses, basically, to fit in. So I have really shitty windows. Oh. What just happened? Okay, I think we found part of the issue. What the hell? This never in my life happened. How? I mean, I'm not trying now, but like, what? I just pushed it in. Okay, let's try this SD card. Maybe we found the issue. Ah, now it works. What the hell? How? I've never seen this in my life. Okay, but yeah, okay. Steve, when you asked whether the SD card is all the way in, you were spot on. I mean, it wasn't. It was in, but what the hell? I think the gremlin theory is like creating some traction here. Um, I've seen it once before personally. Really, like I always thought like SD cards are indestructible. Okay, what was the top of? I mean, maybe something pushed, like there's not like ton of space. Like I kind of like sorted everything, but it could have happened. That's reasonable. Yeah, I think that was not a good place to start a pie. I have one more SD card. Let me grab a fresh SD card, then we flash Clipper. As always, nothing for me is straightforward, right? Okay, let me grab a SD card. 1 second. Okay, never mind. The SD card I have is 2 gigabytes, which is not quite suitable. Okay, then I would say let's just kind of slowly roll up here, or wrap up here is the correct term. I order SD cards, more than one, and because I've never in my life ran out of micro SD cards. That's the first. Time to print more boxes. I actually have like 3 boxes now completed. 1 box kind of went haywire, like it completely warped in one corner. But yeah, this one here is already one of the new ones. Not perfect, but it completed. I'm quite happy. Still has no plexi acrylic glass on top, but lots of screws and lots of heatset inserts. I forgot who asked about it in the beginning, but I have a couple of them spare. How old is an SD card? Maybe just old age. I don't know. Like it's a Raspberry SD card. So like one of the Raspberry SD cards. So I assume 6, 7 years, maybe. Oh, yeah, I think Steve's theory on like something pushed down on it in the box is quite likely. Still, like that's something. Neo, I totally overlooked your messages with the LDO cable. How did you replace it? Yeah. So here's the story what I want to say. Yeah, so I had the exact same issue quite a while ago. Let me actually, I took a macro picture of that. I had a chat with Sue from LDO. So yeah, reach out to 3D Jake. That's exactly where I got mine actually as well. So what I found, this is the picture I sent to LDO. Save. Did not save it. Save. So this is what I saw with a macro shot of the camera. So this is how my crimp looks. This is the LDO cable that broke, and you can see that the casing, the isolation of the cable, was not properly crimped. So basically, you can see that like the tongs here didn't like grab into the cable. These 2 tongs should have been like in the isolation here. And that was not the case, and that's just like shit crimp. That's no other way to say it. And that's partially why it broke. The other part that I kind of found out later, but like just reach out to 3D Jake. They are really good in handling that. You will get a new one, no worries. The other part that I found out later, in the LDO manual, it says that they add this sleeve around the cable. Not sure if you saw that. Quickly close this up. So the V0 from LDO comes with this cable sleeve to put around this like cable, and then you have cable ties on both ends. Yeah, you did that, okay. Because I didn't add the cable ties. What I later figured out is basically these cable ties, they reduce the twisting on the cable, or like on the pins of the cable. But if you have that cable ties on, then you are according to the manual, and then I assume you just have something like this where it's just like a bad crimp. So for me, actually, I think 3 cables in total broke. What I did for the first 2 was I just swapped them with cables I don't need, because there are some connections on this cable wire, like on the cables, that you don't need. So there are 2 cables for there's 1 cable for the X end stop, which you can like replace. So if you get the pins out, like let's say 1 cable is broken, you can remove the cable for the X end stop and swap it with the broken cable. So that still is an option. Can you link me to a tool that's I can get the pin out? You would need to check that. Do you have a multimeter? Like one of those multimeters. If you have one of those, you can just measure it, right? You just put it in connectivity mode, and then you put it to the X end stop pin, and then you just check all the cables and see which one it is. That's the easiest way. Tweezers won't do. You need a specific tool for that. You can. How did I do that? I don't remember how I did it, to be honest. There's a specific tool for that. It looks like this. But this one is too large. I think I couldn't use this because this is for the larger size. But this is how you get out, and then you push it in, and then you get out. What I actually did by now is I ordered some of the microfit connectors, and I also have microfit crimp thingies. So I just like have some on spare now, because like it happened to me multiple times that I had to do those and I never had them. I only have that large one as well. Yeah, you can try the large one. I mean, I cannot remember how I got it out, but I either used the large one or it was just brute force in some way, shape, or form, but I got it out. There was some way to get it out. Used to sewing pins, that's also a good one. That's also a good one. Okay. But yeah, like a bit annoying, but I feel like they maybe just had like a bad batch of those cables. But generally, LDO is really good with handling these type of RMA situations. From my experience, I had two returns with my V0. One was the cable, and the other one was the Z motor. Actually, they had a faulty batch of Z motors, where the coating on the lead screw was too thick, and it caused the POM nut to wear down really quickly. Steve always has good ideas. Yeah, sucks. Sorry for you that you have to deal with that, but at least you have a good printer. So could be worse. Yeah. So then homework for me is to redesign these corner parts, as we discussed plenty before, and that's pretty much it, right? I have to print parts then. So these, yeah, I really try to like shave off like, let's say like 10 millimeters here, something like this. These are not aligned properly, so I would have need to reprint those anyway, so that's not a big deal. Most likely I will print them all in black. I don't think like I want to spare my accent color a bit, so I print these all in black now. And then basically I will modify this part here to have like a connection over here. And then the black part here I can modify to maybe, or like also this part maybe to have like a mounting slot for the screw, for the bed. The only problem is if I do the bed here, the screws need to be insanely long. Because like they need to reach from here like all the way down, because you can only tighten it here, right? And then if you like have it on the bottom, there's also like not a ton of space here for stuff. So we need to be a bit careful where we put the tightening nuts. I think I'm still in favor of the 3-point solution, to be honest. I'm still in favor of the 3-point solution because like here in the middle, there's a lot of space. So we can very easily have the tightening thingy. So it would be a little bit like this here, right? There's like tons of space in front, so that's not a big deal. Like you can have the twisty thingy can twist here. Like that's okay. Will be tight, but I'm also not quite center. Like this is enough space. We can shorten them a bit. We'll be fine. And then in the back, I would just do the center one. So basically that there's like the rods coming here, and then we can just have something in the center for the rod to mount that. Similar to this part, just like then it would be vertical. And then we can also use the twisty thingies. So just need to see, potentially what we do is that these come forward a bit, like that it's like more like a shape like this, that like you have enough space for the twisty thingy in the back here. I'll figure something out. Yeah, but I think the important part really is like that these parts directly are connected. Because also now, like with this part directly here, I can still twist this quite a bit. Like this is not super stiff. And I think if these parts are directly connected, you cannot twist this down anymore, because then you would force this down as well. And yeah, it's way more difficult. So I think that's a good idea. And then here, this is fine. There's then also enough space. And then yes, we lose like 15, 20 millimeters of vertical space, but then so be it. So be it. I love the little thing. I wish it built sooner. Yes, I love it too. But mine needs a bit of maintenance. I think actually next stream we will do will be the V0 maintenance stream, basically. Because I feel like it's the belts are a bit loose. We need to check that. I'm kind of low-key considering moving it to canvas. Let's see about that. Yeah. Will the switch wire printer mount that will span the rear to mount belts? It could. It could be one part. It could be one part for sure. It's just like, so far, all of those parts are printable on the V0. And that's kind of like what I would like to continue, that all those parts are V0 printable. So I think like, yeah, I'll just use like 2 rods here to connect that. There's enough space, like we have tons of space here. That's super cool. And then these like purple parts really like, they can just like come out a bit again. Like I can add like whatever I want here, right? So they can just come forward a bit to like roughly here. And then we can have a clamp that goes back, like this clamp goes back again. The only thing that I don't like about that is then you re-lock in this bed. Like right now, it's completely flexible. You can build, you use any bed you like, right? With these two here, I can still use a V0 bed if I want, right? I just have the bed and like super center. But I mean, technically also like nothing is stopping you on adding these parts later on, right? So if you want to have different beds that doesn't fit on those mounts, you can still use this solution in the middle. I don't have to delete it, right? I can keep those parts. So that works. Yeah. I just don't delete those parts from the project. And then technically, like if you want to mount the ender bed, like right, like you can make this bigger and then you mount the ender bed on the corners. Also, ender bed on the corners won't quite work because they're not as close to, like the holes are further inward. Yeah, I'll leave those parts in the project because they work. Just like this needs to be higher up, but that's a different topic. Yeah. EBB36. Yes, EBB36. Oh, I don't have it here. Yes, I have one EBB36, which technically should go on this machine here. Right there. There's the EBB36 hole. But I also want it on a V0, to be honest. So potentially I just order another one. My main problem is we will find a solution, but we need to, if we want to V0 if the V0 needs CAN, we need to add this tool, this board here somewhere, right? And it's not big, but it's a V0, so everything is very small. So we need to see. Maybe we just do it like spontaneously on stream. Just see if we find a solution for that. If yes, we do it. If no, we don't. Yeah, but then basically next week I'm not home, so there won't be a stream next week. And then the week after, potentially V0, maybe this machine, depends a bit how much time I have to redesign everything. So I'm basically not home for like 1.5 weeks, so I also can't really print parts. That might also be a bit of a problem. So let's see what we do next time. But I think like, in general, like this is good progress, right? So it moves up and down. That's my main thing. It moves up and down. We learned tensioning is a little bit tricky. But I think really like what you mentioned, like this needs to be tensioned like the Ender 5. So you need to loosen those pulleys here. The only problem then is that the pulleys will not be on the flat side anymore, right? So if you loosen that, you tension it, like the pulley will twist. And then it's not on the flat side anymore of that rod. I don't think it's a big deal, but this is what will happen. I can't miss it. I think the rods are fine. But could you always print an adapter to add a different bed? I mean, you can always add an adapter, right? It's just that you lose that, then you lose that. But that's what I mentioned. Like you can always, I mean, these parts here, they work, right? This is a valid bed mount. You can always just keep these parts in the project. And then if somebody wants a different bed, this thing exists and you just ignore those mounts and you add these in the middle. And then you can, because this allows you to mount any bed, right? You can have 2, 1, you can move them back like sidewards, you can move it forward, you can mount any bed. Pull one side tight if the pulleys are not loose. Yeah, exactly. That's what I also kind of like figured out, right? One side you tension and the other side is loose. Having 2 pulleys on the motor, yeah. So we need to, I mean, now it's kind of tensioned. and somewhat similar tension on both sides. So it's kind of fun. But yeah, for me, like this moves up and down and this is quite sturdy. Like it will be even more, if these are connected directly, this will be even more sturdy. So I'm quite happy with that. It's also funny, like how much you can like pull it out of whack. Oh, funny. Look at this. This is also definitely not aligned here. So I need to double check these parts. Like there's something off with the belt path. There's definitely something off with the belt path. I mean, if you look now from the front, you see it really clearly. Like that's not straight here. There's definitely something off with the belt path. Yeah, I'll check that. And we have to reprint these parts anyway, so. Cool, okay. Done. Yeah, Neo needs to be shifted, but like in Fusion, it's aligned. In Fusion, it's aligned. I'm pretty sure about that. That the top pulley and that thingy is aligned. So I'll check it. Something's off. We'll find it. A little bit of debugging. Cool. Then, yeah, thanks everyone for tuning in. As mentioned, next week no stream, but then the week after I'm back. So enjoy your weekend and see you next time. Bye.